The study of energy changes in chemical reactions is a key focus in the field of thermodynamics. One such energy change is the enthalpy change, which represents the heat exchanged at constant pressure. In this experiment, we aim to determine the enthalpy of neutralization for the reaction between hydrochloric acid and sodium hydroxide, a classic example of an acid-base neutralization. This is an exothermic reaction, meaning that heat is released as the acid and base react to form water and salt. The standard enthalpy of neutralization for strong acid-strong base reactions is typically around negative 57.3 kilojoule per mole, as it primarily reflects the formation of water from hydrogen and hydroxide ions. In this experiment, a coffee cup calorimeter, a simple calorimetric setup using an insulated cup with a lid, a thermometer, and stirrer, is used to minimize heat loss to the surroundings. The materials required are weighing jar, 1 molar HCl solution, 1 molar NaOH solution, a thermometer, a polystyrene coffee cup calorimeter, a stirrer, and a lid. Before starting the experiment, all equipments are washed thoroughly to avoid contamination and ensure accuracy. We begin by accurately measuring 25 milliliters of 1 molar HCl in a clean glass jar. The measured HCl is poured to the calorimeter to measure the initial temperature. Next, 25 milliliters of 1 molar NaOH is measured in a separate glass jar. The initial temperature of both the solutions are then recorded using a calibrated thermometer. Following this, the sodium hydroxide solution is poured into the calorimeter containing the hydrochloric acid. The cup is immediately covered with its lid, and the mixture is stirred gently but continuously to ensure complete reaction. Finally, the highest temperature reached is noted, which allows us to calculate the heat released and the enthalpy change of the reaction.
Now let's move on to the calculation part. In this experiment, we are determining the enthalpy change for neutralization reaction between NaOH and HCl. The balance equation is NaOH plus HCl gives H2O plus NaCl. The initial temperature is 36.5 degrees Celsius and final temperature is 43 degrees Celsius, giving a temperature rise of 6.5 degrees Celsius. Volume of NaOH used is 25 ml and volume of HCl used is 25 ml. Therefore, total volume of final solution is 50 ml. Assuming density is like water, mass of the solution is 50 gram or 0.05 kg. C is equal to 4.18 joule per kg degree Celsius. Using the equation Q is equal to minus mc delta T, we get minus 1358.5 joules. Number of moles of HCl is 0.025 mole and number of moles of NaOH is 0.025 moles. Moles of H2O is 0.025 moles. Finally, using the equation delta H is equal to Q divided by number of moles of H2O formed, we get minus 54.34 kilojoule.
For this experiment, we used 1 molar hydrochloric acid and 1 molar sodium hydroxide. The MSDS states that both are corrosive and can cause burns to skin and eyes. So we wore lab coats, gloves, shoes, and we handled the solution carefully to avoid splashes. If contact occurs, the MSDS recommends flushing with water for at least 15 minutes and seeking medical attention. Following these guidelines ensured we carried out the experiment safely while obtaining accurate data.